The objective of this lesson is to use reasoning to compare and contrast triangles and place subcategories of triangles into a hierarchy. In previous lessons, students organized quadrilaterals using Venn diagrams, tree diagrams, and concentric circle diagrams to show their hierarchy. Students have learned how to measure angles and identify angle types. Today's lesson is a task-based lesson, and students will work to create a hierarchy of triangles. Here are some triangles. Let's start by identifying the angle type and then look for congruent sides. The first triangle has an angle measurement of 90 degrees, or it is a right angle. This is shown by making the angle a square. The other two angles are less than 90 degrees, so they are acute. All the sides are different lengths. This can be shown by marking 1 line, 2 lines, and 3 lines along the sides. The second triangle has congruent and acute angles. These can be marked like this. All the angles are acute and all the sides are congruent. Continue marking the triangles with their angle types and whether or not the sides are congruent. One way to sort the triangles would be according to the sides. Let's use a Venn diagram to organize the groupings. The first group will be no congruent sides, or scalene. The second group will be 2 or more congruent sides, or isosceles. And the last group will be 3 congruent sides, or equilateral. The first triangle has no congruent sides. It will be placed in the first circle, so it is a scalene triangle. The next triangle has 3 congruent sides. It can be placed in the equilateral group because it has 3 congruent sides. It can also be placed in the isosceles group because 3 congruent sides is 2 or more. In order to show this, let's overlap the two groups and place the triangle in the middle. The next triangle has 2 congruent sides, and it will be placed in the isosceles group. It cannot be placed in the overlap of isosceles and equilateral because in order to be equilateral, it must have 3 congruent sides. Continue placing the triangles in the correct groups. Let's draw some conclusions about the relationships between the groups and the triangles. What do they all have in common? They are all triangles and they all have 3 sides. The overarching shape is a triangle. Let's create a tree diagram to model the relationships. The top shape would be a triangle. Notice that the scalene group does not have anything in common with the other two groups. This means that an isosceles triangle and an equilateral triangle will never be a scalene triangle, and vice versa. Scalene will be its own subgroup of a triangle. Let's take a look at the isosceles triangles and the equilateral triangles. All equilateral triangles are isosceles triangles. However, not all isosceles triangles are equilateral triangles, as shown with the portion of triangles not in the overlapping section. This means the next subcategory under triangles would be isosceles. Because all equilateral triangles are also isosceles, equilateral is a subgroup of isosceles, and they are a subgroup of triangles. Triangles are actually a subgroup of the term polygon. A polygon is any closed shape with at least 3 sides. Let's bring up the hierarchy of quadrilaterals from a previous lesson. Quadrilaterals have 4 sides and are closed, so they too are a subgroup of polygons. In fact, many other known shapes can also be added under polygons. Pentagons, hexagons, and so many more. The objective for this lesson was to use reasoning to compare and contrast triangles and place subcategories of triangles into a hierarchy. We met this objective by identifying triangles' angles types, as well as the amount of congruent sides. We used a Venn diagram to organize our thinking and created a tree diagram to show the hierarchy of triangles based on the amount of congruent sides.